Hey Rustaceans! Welcome back to Rust Run. Today we're tackling one of the most iconic LeetCode problems out there. Problem number 11, container with most water. This challenge pops up all the time in coding interviews, so if you want to ace those technical screens, you're in the right place. As usual, our first step is to read the problem description just like it appears on LeetCode. So, you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0, and I, height of I. We need to find two lines that together with the x-axis form a container, such that the container contains the most water, and return the maximum amount of water a container can store. Notice that you may not slant the container. Now, if that sounds a little confusing, you're not alone. Let's bring it to life with an example. Take a look at this visual. Each vertical line represents a value from the array. Our height array is 1, 8, 6, 2, 5, 4, 8, 3, 7. The two red lines you see form the container that holds the most water. The water level is set by the shorter of these two lines, and the area is calculated by multiplying that height by the distance between them. Here, the shorter line has a height of 7, and the distance between the two lines is also 7, giving us 7 times 7, which equals 49. If needed, feel free to pause the video and read the description a few times, or replay this explanation until it fully clicks. Before jumping into the optimal solution, let's take a moment to understand the most common first idea, the brute force approach. We start by checking all possible pairs of lines. First, we fix the left pointer at index 0 and try pairing it with the line at index 1. The area is calculated by taking the shorter of the two heights, which is 1, and multiplying it by the distance between them, which is also 1. So, the area is 1. We'll keep that as our initial maximum. Next, our algorithm would fix the left pointer at 0 and move the right pointer to index 2. We calculate this new area, which is 1 times the distance 2, giving us an area of 2. This is now our new maximum. This process would continue, checking every single possible pair of lines. As you can see, for an array with n elements, this would require n times n comparisons. This quadratic time complexity, or O of n squared, becomes incredibly inefficient as the array size grows. This is exactly why we need a better, more clever approach. Alright, now let us move to the smarter way, the optimal two-pointer approach. Unlike brute force, which needed 36 comparisons, this method will only need 8. Let us see how it works. We start with two pointers at opposite ends. The left pointer is at index 0 with height 1. The right pointer is at index 8 with height 7. The width between them is 8 units. The water level is limited by the shorter line, which is height 1. So our area is 1 times 8, which equals 8. That is our starting maximum. Here's the big idea. Always move the shorter line toward the center because the area is limited by the shorter height. The only way to increase the area is to look for a taller line to replace it. That is why we move the left pointer inward. The left pointer moves to index 1, which has height 8. Now we've got 8 on the left and 7 on the right. The shorter height is 7 and the width is 7. So the area comes out to 49. That's a big jump and it's our new maximum. From here, we just keep following the same rule. Always move the pointer at the shorter line toward the center. Each time we move, we calculate the new area and update our maximum if we find something bigger. Sometimes the area will drop, sometimes it will go up, but we never skip a combination that could beat our best so far. We repeat this process until the two pointers meet, and by then we have checked every promising pair in only a fraction of the time it would take with brute force. Alright, now that we understand how the two-pointer method works, Let us bring it to life in code and see it in action. Let us code this up. First, we set up our 2 pointers. Left starts at 0, and right starts at the last index in the array. We also create max_area to keep track of the best results so far. Next, we run a loop while the left pointer is still to the left of the right pointer. Inside the loop, we calculate the width, which is simply the distance between the 2 pointers. Then we find the current height, which is limited by the shorter of the 2 lines. We multiply the width by this height to get the current area. And if this area is bigger than our max so far, we update max area. Now comes the key part. If the line at the left pointer is shorter, we move the left pointer 1 step in. Otherwise, we move the right pointer 1 step in. This way, we are always looking for a taller line that might increase the area. When the pointers meet, we return max_area. And that is our efficient O of N solution for the container with most water problem. Looks like we are ready to submit. And as usual, our solution beats 100% of submissions on LeetCode. The time complexity is O of N, since each pointer moves at most once through the array. The space complexity is O of 1, because we only use a few variables regardless of the input size. You actually made it to the end, which means you are officially smarter than when you started. But I am also 100% sure you forgot to subscribe. Go ahead, click that button, it is free, and it makes me feel like all this caffeine was worth it. Oh, and give the video a like before you go.